Okay, so welcome to part two. Now we're going to take a look at a second example using R to handle pivot tables. So back to our original R file, pivottables.r, which again is available in the DAT6102 directory. So yeah, right. What we're going to do here is I've made a query to our SQL database. And I've stored that query into a data frame called pivdf for pivot data frame. And the first thing I'm going to do is I'm going to, well, actually, I guess the first thing that I'm going to do is show you that data frame. So let me go ahead and run this query. And in a moment, or maybe longer, that data frame should be appearing in our environment tab. Okay, there it is. Good. So yeah, let me open it up and show you what we got. So here it is. You guys should be familiar with this. This is essentially our jobs view table. So what I'm going to be doing here is the following. I'm going to go ahead and I'm interested in looking at job stats for the different schools and the different groups within those schools. And I'm going to break the jobs up into three categories. I'm interested in looking at the jobs that have completed, those jobs that have failed, and those jobs which were canceled. And I'm going to look at some of the various metrics, various statistics for those three categories. So the first thing that I'm going to do is I'm going to use our filter function, and I'm going to filter our pivdf data frame by state. And the three categories within state that I'm interested in are completed, failed, and canceled. So okay, let's go ahead and run that line. All right, and I've created now a new frame called basic. And let's go ahead and take a look at basic. So basic only has those jobs which fall into one of these three states: canceled, failed, and completed. All right, so far so good. Notice the syntax, by the way, for selecting the different categories in the state variable. It's the percent in percent symbol. Okay, so the next operation we're going to perform is a group by statement. So I'm going to take that data frame categorized by state with in completed, failed, or canceled states, and I'm going to group by the long group name and state. So let's go ahead and run that. Easy enough. And now if I go ahead and if I look at basic group, it's essentially the data frame is essentially the same, except with some additional metadata attached to it. And then finally, what I'm going to do is I'm going to summarize the basic group table based on the following variables. So runtime hours, which is going to be the mean of the runtime, so the average runtime. Now runtime is in seconds, so I'm going to divide by 3,600 to get into units of hours. So runtime hours is going to be the average runtime. The number of nodes is going to be the mean number of nodes in a particular job. Wait time hours is essentially the average of the wait time, and again that's in seconds. So I divide by 3,600 to put that into units of hours. The number of CPUs, so the average number of CPUs in a job, and then something that I'm just calling SUs. And so SUs is going to be runtime divided by 3,600 to put me into units of hours times the number of nodes. And this is going to be done on a case-by-case basis. So for every line in my table, I'm multiplying the runtime and by the number of nodes. So let's go ahead and execute that line. And I've got something now called basic sum. And I can even pull up basic sum and let you see what that looks like. So here's my basic sum table. And so you'll notice that it's already categorized by long group name and the three different states: canceled, completed, failed. There were no canceled jobs in astrophysics, so we just have completed and failed, and so on and so forth. All right, next step. So now what we're going to want to do is cast that summarized table by long group name in the y-axis and state on the x-axis, and the value that we're going to be regrouping by is going to be runtime hours. So let's go ahead and do that. I'm going to assign it to a name, so I'll just call it basic cast. That seems good enough. So I'll run that, and let's take a look at basic cast. Here we go. So we're actually getting close here. So I've got the groups, and what I'm doing now is I've pivoted the table. So instead of having canceled, completed, failed as values in a column, I now have canceled, completed, and failed as column headers of their own, and the cells, the fields that they're, the values of these fields is now populated by runtime hours. Okay, so let's keep going. Let's save this. So now what I'm going to do is a slightly more advanced pivot, and I'm going to melt my basic sum table. And remember, we talked about melts in the last video. So what melt does is it takes a wide table with many columns and collapses it into a table with fewer number of columns, a long table with fewer columns. In this case, I think we're only going to have 3. So yeah, what's going on here? We're going to melt the basic sum table. The variables, the identification variables that we're using are long group name and state name. And now something to point out here. When you set your ID variables, you want to go from left to right. You want to use the variables that change slowest on the left side and the variables that change faster on the right-hand side. And you can experiment for yourself by transposing these to see what happens if you were to put state first and then long group name second. In other words, if you put the fast-changing variables first and then the slow-changing variables, your table comes out. It's still a melted table, but it gets a little bit messy when you try to recast it. So anyway, yeah, keep the slower changing variables on the left-hand side and the faster changing variables on the right-hand side. My measured variables are going to be runtime hours, number of nodes, wait time hours, number of CPUs, and that quantity that I'm defining as SU. So let's go ahead and run that. So now we open up our basic sum 2 table, and this is a melted table. And you'll see that the ID variables are long group name and state, and this is the reason I had the slower changing variables first, because I wanted to group all of the groups together. So Bolaris group, Bolaris group, Bolaris group. This changes slower than the state variable. This changes at every row. This changes every 3 rows. My variable now is going to be, well, runtime hours. What were the other ones? Good question. What were those? Yeah, runtime hours, runtime hours, number of nodes, wait time hours, number of CPUs, and SU. So if I scroll down, keep going, we'll see how this changes. Yeah, so for example now, number of nodes follows runtime hours in the same column. So essentially what I've done to summarize is I've taken my wide table, which number of nodes, wait time hours, and so on and so forth, where these are all individual columns, and I've collapsed them into one single column, and whatever value they hold is going in the value column. Now another important point to take note of is this only works if the values are all of the same type. If some of the values are strings, like so for example the names of people or what have you, I couldn't mix those with numbers. The only columns that I can combine into a single column have to be storing the same data type. Well, now that this table is melted, I can continue on and I can recast it in whatever form I want. So the form that I'm going to recast this as is going to be, I'm going to be using long group name on my y-axis in the state plus the variable on the x-axis. And what is variable again? So the form of the table I'm going to be recasting basic sum 2 into looks like the following. I'm going to have long group name on the y-axis and then state plus variable on the x-axis. And again, what is variable? Variable is the following. Variable is going to be runtime hours, number of CPUs, number of nodes, etc., SU, etc. And of course, that's the header name of the column. So that header name goes here. Goes where? Yeah, there it is. It goes there. So I'm going to be looking at state plus the different variables in that column. And the aggregate function I'm going to be using is sum. And the value variable is going to be value, and a value again, like variable, means I'm going to be summing over the values in the value column. And I'm going to do something a little bit different here too, which is similar to what I'm going to be showing the sum in the margins, or I'm going to be marginalizing these sums, and that is similar to what we did here in our Google sheet, where we were we took the sum of the quarters and put those total sums in the margins. So let's go ahead and do that. Let me run this. And it looks like we're done already. So let's open up BigPiv. So now I have the different groups, and again I've melted and recast this table so that the categories that were originally in the variable column are now column headers of their own. So this will be canceled runtime hours, canceled number of nodes, canceled wait time hours, canceled number of CPUs. And let's move over a little bit further. And then we start over. Now we're doing completed runtime hours, completed number of nodes, and so on and so forth. Failed runtime hours, failed nodes, all for the same group. For each group it falls into a single line. And then lastly, remember I'm going to marginalize over the sum of the canceled runtime hours, canceled number of nodes, etc. Essentially, I'm going to be looking for the total for all of these columns. And those values are marginalized in the last row titled all. So essentially what we're looking at is the sum of all the columns in the last row here. And that concludes this demonstration of creating pivot tables in R. Thanks a lot.